And here's the last one from 6.6. This is number 3. Same thing. You need to state the possible rational zeros for this function and then find all of the rational zeros that would satisfy this equation. But remember, they have to be rational. So let's take a look at this problem. So we have 2x to the third plus 3x squared minus 1. Again, we always start with putting the last term over the first term. Oh, that was interesting. Let's fix that up. Here we go. And that would be the last one is 1. And the first one is 2. So it's 1 over 2. I'm going to write that down here because we need to find the factors now. Let me move these down a little bit. Put them on this page. And work this out. All right, so I said it was 1 over 2. So we need to find the factors of 1 over 2. Okay, so we know it's going to be for 1, it's just simply plus or minus 1. That's all there is for that one. And for 2, we would have plus or minus 1 and plus or minus 2. So let's put each one of these over top to find the possible rational zeros. We had to put that 1 on the top, on top of each one of the terms on the bottom. So we would have, the first one would be plus or minus 1 over 1. So we'll just leave that as plus or minus 1. The second set would be taking that plus or minus 1 and putting it over the 2. So we would have plus or minus 1/2. Okay, so those would be our possible rational zeros right here. Now there's not too many there. We could probably use the, excuse me, the synthetic division to figure out which ones actually would work. But why don't we do this instead? We'll go ahead because we're trying to learn how to use our calculators to do this. So let's take a look at when I put this into the calculator. You can see right there that I have the equation right here plugged in. And you can see, let me kind of expand this a little bit. You can see where my graph is touching each of the points on the x-axis. So the question is are each of those rational? If not, we need to figure out which one is rational. So let's take a look at this. So when I actually touched those on my graph, it provides these two x values here. We have a -1 and we have a 0.5. Well, if we go back to looking at our possibilities, that fits there, doesn't it? Let me write these down here. Plus or minus 1. We have plus or minus 1 and plus or minus 1/2. Okay, so let's look at this. And they're always written as integers, so a ratio. As a ratio. Okay, so the 0.5 would actually be a positive 1/2. Okay, so we can see here then that a -1 works and the positive 1/2 works. Now, there's another part of the answer that I went back and listened to the video. He doesn't actually cover this in this particular lesson, but notice that in the answers here, you have these, looks like multiply, but what that stands for is multiplicity. And typically what that means is, and I'm questioning why he didn't cover this, because I noticed in the first problem of this lesson, he doesn't have a multiplicity in the potential, in this rational zeros for the answers, but he does in this one, but yet he didn't cover it, unless I missed it somewhere, but it's not in the video that I watched. So let me see if I can give a good description as to the way I understand it. When you have points crossing the axis, the x-axis, okay, I want you to notice this. I'm going to erase some of this because I actually want to clear this off so you can see the difference here. Notice how the graph comes up right here, touches this point at -1, 0, and then actually turns around and goes in the other direction. So the multiplicity of this one means it's going in one direction, touching that point, and touching the point to go in another direction. So in a sense, it's like it's touching that point twice. It's not going directly through it one time. It's touching it and turning around. So you can kind of see that as two movements on the point. Okay, so that being said, our rational zeros rational zeros would be, let's go up here and write this, would be the positive 1/2, okay? And then we had the negative 1 with a multiplicity of 2, meaning it touched that graph kind of like twice, if that makes sense. It's got 2 movements there at that point. But so did our first problem on the graph, so I'm not really sure why he addresses it in the answers on this one and not the other one. But maybe you saw him describe that to you when you did your lesson with him last week. I'm not really sure. So anyway, if you have something to enlighten me on with that one, that would be great too. But that's my understanding of the multiplicity of 2 at that point, negative 1, 0. Okay, so that would be the answer. So if we went up here and tried to find that answer, you're looking for positive 1 and positive plus or minus 1 and plus or minus a half for the possible rational zeros, and then 1/2 and then negative 1 with the multiplicity of 2. It looks like it's this one right here. Okay, so that's how you would do that problem. Hope that's helpful.